I'd be like, whoa, okay. But I think we'll literally build a legion, or at least one legion of robots this year, and then probably 10 legions next year.
30 minutes, not to bake a pizza, but to roll out a humanoid robot. So what exactly is happening inside Tesla's factory? Thanks to a modular plug-in design for 28 actuators, the FSD chip, and a suite of sensors, each Optimus robot can be assembled in just half an hour at an unprecedented speed in the world of robotics. How has Tesla achieved what companies like Figure AI, Agility Robotics, and Boston Dynamics are still struggling to prototype? Before we begin, please help us reach 4,300 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus, Tesla Model Q, Tesla EVs, and the latest news. How can Tesla build Optimus in 30 minutes? Producing an Optimus robot in just 30 minutes is a feat that Tesla is achieving in the field of humanoid robotics. Of course, this accomplishment is not a matter of luck, but the result of extremely high-level optimization of the assembly process, with core technologies directly inherited from Tesla's electric vehicle production lines. Tesla applies a modular design approach to the manufacturing of Optimus, allowing major components such as the skeletal frame, actuators, battery, and control computer to be assembled simultaneously and rapidly before final integration. Elon Musk once emphasized during a presentation.
So the new Optimus 22 degree of freedom hand and forearm is now in production. And it's learning to walk and catch balls. It's pretty cool. I mean, look, that's where we came from. It's wild. So in a very short period of time, Optimus has gone from being an idea to the most sophisticated humanoid robot on Earth.
The Optimus assembly process can be divided into multiple stages, starting with the preparation of individual modular subassemblies. The robot's frame is precast from lightweight alloy, potentially using gigacasting technology similar to that used in the Model Y production line, which helps minimize the number of components and assembly steps. At the same time, the actuation system, which includes 28 actuators responsible for joint movements in the arms, legs, and spine, is also prepared in advance. This is one of the most complex and time-consuming stages we have observed, as each actuator must be calibrated with millimeter precision to ensure the robot can move fluidly and maintain balance. Even a small deviation could lead to poor mobility or instability. In particular, the hands and forearms, which feature 22 degrees of freedom, form one of the most technically intricate modules, accounting for nearly 50% of the robot's entire electromechanical complexity. Elon Musk once revealed this during a presentation.
Yeah.
The hand might be close to half of all the engineering in Optimus. From an electromechanical standpoint, the hand is probably roughly half of the engineering.
The hand design has undergone numerous trials and refinements. In the early stages, the engineering team experimented with integrating actuators directly into the palm, but they quickly realized the limitations of this approach.
We tried putting the actuators in the hand itself, but then you sort of end up having these like
Giant hands?
Yeah, giant hands that look weird.
Producing an Optimus robot in just 30 minutes is a feat Tesla is achieving in the humanoid robotics space. This milestone is not a matter of luck, but the result of extreme optimization in the assembly process, leveraging core technologies inherited directly from Tesla's electric vehicle production lines. The assembly process for Optimus can be broken down into multiple steps, starting with the preparation of individual modules. The robot's skeleton is precast from lightweight alloy, possibly using gigacasting technology similar to what's used in the Model Y, which reduces the number of parts and assembly operations. Simultaneously, the drivetrain system, including 28 actuators responsible for joint movement in the arms, legs, and spine, is prepped for installation. This is one of the most complex and time-consuming steps, as each actuator must be calibrated with millimeter-level precision to ensure fluid movement and balance. Even a small misalignment can result in instability or inefficient motion. The arms and forearms, featuring 22 degrees of freedom, are the most intricate part of the robot, accounting for nearly 50% of the electromechanical complexity. As Elon Musk revealed, the hand design went through multiple iterations and adjustments. In early stages, engineers tried integrating the actuators directly into the palm, but quickly discovered significant issues. As a solution, Tesla repositioned the actuators externally and used an ultra-compact cable and gear transmission system, maintaining precision while keeping a clean, natural appearance. Next, the 2.3 kilowatt-hours, 52-volt central battery is mounted into the midsection of the robot. Wiring and connectors are designed in a plug-in format, enabling quick and precise installation. The brain of Optimus, the full self-driving FSD computer combined with a neural network, is added last, responsible for coordinating sensors, computer vision, and motor control. Once the hardware is complete, the robot enters a full calibration phase, where cameras, force sensors, and motion systems are auto-aligned. The robot then performs a series of basic movements like walking, bending, and gripping objects to verify that all systems are functioning properly. This entire process takes place on a nearly fully automated production line where industrial robots handle the majority of tasks, demonstrating Musk's long-held vision of robots building robots. The reuse of shared Tesla EV components, from the FSD chip, battery wiring to sensors, helps cut production costs, leverage existing manufacturing capabilities, and dramatically shorten development time. Furthermore, testing and calibration stages are AI-driven, allowing real-time quality control and eliminating outdated manual inspection steps. Based on these stages, we believe the core factors enabling Tesla to reach the 30-minute production benchmark lie in three critical elements: modular design, full automation, and reusing EV technologies. Among all steps, installing and calibrating the actuators, especially the hand with 22 degrees of freedom, remains the biggest challenge, requiring extreme precision in both mechanical systems and control software. If Tesla's team can further optimize this phase, the total assembly time could drop to just 20 minutes. Tesla has achieved a major breakthrough in humanoid robotics by completing one Optimus robot every 30 minutes. This achievement places Tesla far ahead of competitors like Figure AI, Agility Robotics, and Boston Dynamics companies still in manual or semi-manual production stages, where assembly time ranges from hours to even weeks in the case of Atlas. Figure AI's Figure 01 has only reached the prototype stage, with assembly still experimental and far from scalable. Meanwhile, Agility Robotics Digit has entered limited commercial production at the RoboFab facility in the US, but initial capacity is only about 10,000 robots annually, around 27 per day, meaning each takes 1 to 2 hours to assemble, excluding testing and calibration. Boston Dynamics Atlas remains a tech demo with no mass production line or viable commercial path at reasonable cost. Tesla, on the other hand, is executing its robots building robots strategy by relying heavily on industrial robots to assemble Optimus. Most stages of assembly and calibration are automated, minimizing human labor. Shared components like the 2.3 kilowatt-hour to 52-volt battery, FSD computer, wiring, and force sensors are all plug-and-play, accelerating the build process. Unlike competitors who must design each part from scratch, Tesla directly repurposes proven EV components, a competitive edge that's nearly impossible to replicate quickly. This not only slashes costs, but also reduces the time from design to mass production. As a result, a single line can produce 2 robots per hour, or 16 per day. With 10 lines running in parallel, Tesla's theoretical output could exceed 50,000 to 100,000 units per year, several times the combined production capacity of all its competitors. If Tesla truly maintains a 30-minute per unit rate, then what Elon Musk is building is not just a technical achievement, it is a seismic shift in manufacturing cost and the widespread adoption of humanoid robots. With near-zero labor costs, shared EV components driving down part costs, and AI-led testing eliminating manual inefficiencies, the production cost of each Optimus unit could drop below $20,000, a shocking figure compared to current humanoid robots that cost hundreds of thousands. Once again, please help us reach 4.3 thousand subscribers. This is important for us to stay motivated. Thank you. What makes Optimus production faster than any rival? If a single production line can complete one Optimus in 30 minutes, then with just 10 lines operating 20 hours a day, Tesla could produce up to 9,600 robots per month or more than 100,000 robots per year, with the unit production cost significantly reduced thanks to economies of scale. Reducing the assembly time of one Optimus to just 30 minutes is not only a technical breakthrough, but also a highly effective cost optimization strategy. In industrial manufacturing, assembly time is directly proportional to cost. The shorter the production time, the lower the labor costs, line operating expenses, and depreciation of fixed assets. Unlike current humanoid robots, which often take weeks to handcraft and cost hundreds of thousands to millions of dollars, Tesla is building Optimus on a decade-optimized electric vehicle manufacturing platform. By reusing components like batteries, wiring systems, FSD computers, and sensors from its EV lineup, Tesla saves significantly on both R&D and production. Coupled with a modular design and fully automated assembly, both component and labor costs are substantially reduced. From a financial perspective, Elon Musk once hinted that the future production cost of Optimus could be less than a car, and with the current pace of production, that goal seems entirely achievable. Assuming the production cost of a Model 3 is around $25,000 to $28,000, then Optimus could aim for a sub-$20,000 price point when mass production begins. This opens up a massive market, where companies can deploy humanoid robots as part of their workforce, with initial investment costs lower than a single year's salary for a human worker. Tesla is rapidly approaching its ambitious goal, producing 1 million Optimus robots per year by 2026, a figure that once seemed unimaginable in the humanoid robotics space. However, when viewed through the lens of technology, production processes, supply chains, and market demand, this is not just an achievable goal, it's an extremely strategic move. First, from a market perspective, Optimus doesn't need to look far for customers. Tesla's internal manufacturing ecosystem, with hundreds of thousands of employees across its gigafactories worldwide, already represents a massive potential market. If Tesla replaces just 10% of its workforce with robots, it could immediately absorb 100,000 to 200,000 Optimus units, not to mention sales opportunities in other industries. One particularly promising field is warehouse automation and logistics, where companies like Amazon, DHL, or FEDEX are facing rising labor costs and an urgent need for automation. From a manufacturing standpoint, assembling one Optimus in just 30 minutes is revolutionary. At this rate, a single line could produce approximately 5,800 robots per year. To reach the 1 million unit target, Tesla would need to deploy about 170 to 180 lines operating continuously, a completely realistic scenario if it builds 1 or 2 dedicated factories modeled after its gigafactories. On the software side, once considered the greatest hurdle in robotics, Tesla is taking a radically different approach. Instead of years of theoretical AI research, Tesla uses a unified neural network already trained on billions of miles of real-world driving from its autonomous driving program, along with learning by demonstration techniques. This is a pragmatic strategy that dramatically accelerates the real-world applicability of Optimus without the need for academic-style research cycles.
I mean, I think we'll be making tens of millions of robots a year type of thing. It's like serious volume. Maybe 100 million robots a year.
In the world of robotics, Tesla Bot Gen 3 seems to be dominating. However, formidable challengers priced under $3,999 such as UBTECH Walker S, Unitree GoTo, and UBTECH Alpha Mini are emerging, ready to compete for the top spot. The U.S. robotics market is also expanding rapidly, with over 37,000 industrial robots installed in 2023, accounting for 68% of total installations in the Americas. How can they disrupt the market and challenge Tesla's dominance? Before we begin, please help us reach 830 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Model Q, Tesla EVs, and the latest news. 1. UBTECH Walker S. UBTECH Walker S may be a relatively new name to many, but it is undoubtedly one of the most noteworthy humanoid robots in the mid-range price segment today. Developed by UBTECH Robotics, a leading technology company based in China, Walker S was first introduced at CES 2018 and has undergone continuous improvements. With the ambition of making personal assistant robots more accessible, its price of approximately $3,999 has surprised many in the robotics industry. But how does Walker S stack up against Tesla Bot Gen 3? While Walker S achieves its price point through cost optimization, using composite plastic materials instead of high-end alloys, and a simpler gripping mechanism, Tesla Bot Gen 3 takes a different approach. Tesla's humanoid robot is designed with highly articulated hands, allowing it to manipulate objects with precision, something Walker struggles with due to its clamp-like grip. Another key difference is their intended purpose. Walker S is primarily designed for light household and office tasks, reducing its need for expensive industrial-grade sensors or high-torque servo motors. This contrasts with Tesla Bot Gen 3, which is engineered for more complex tasks in industrial and scientific environments. Tesla's robot is backed by a powerful AI system that enables it to learn and adapt quickly, whereas Walker S has a more limited AI, focusing mainly on voice and facial recognition for home-based interactions. In terms of movement, Walker S features an advanced servo system that allows it to balance, walk smoothly, and even climb simple stairs, making it a significant step forward in personal robotics. However, Tesla Bot Gen 3 surpasses this with its ability to navigate through more complex environments, leveraging Tesla's neural network and full-body motion control for superior mobility and adaptability. Visually, Walker S is compact and friendly-looking, standing at approximately 4.75 feet tall and weighing around 170 pounds. Its LED screen displays emotions, enhancing user interaction, while its arms have a slight curve to mimic natural posture. Tesla Bot, on the other hand, is designed with a sleek, futuristic aesthetic that leans more toward functionality than human-like interaction, with its minimalistic face and streamlined body built for efficiency. Walker S's AI allows it to recognize multiple voices and remember its owner, making interactions feel more personal. It also utilizes object recognition sensors and spatial mapping to navigate around a home safely, much like Tesla Bot. However, the Tesla Bot's AI is on another level, as it integrates into Tesla's broader AI ecosystem, giving it real-time data processing capabilities that Walker S lacks. Despite these differences, Walker S still has strong market potential. While Tesla Bot Gen 3 aims to revolutionize industries with its advanced features, Walker S remains a practical, affordable choice for those seeking a basic humanoid assistant at home. If you're looking for a robot that can perform everyday household tasks and interact in a friendly manner, Walker S may be the right fit. However, if you want a humanoid machine capable of handling complex work environments and evolving through machine learning, Tesla Bot Gen 3 is the more powerful option. So, which one is the smarter investment? That depends entirely on your needs. Would you prefer an accessible home assistant or an AI-driven industrial powerhouse? The future of humanoid robotics is unfolding before us. Are you ready to be a part of it? 2. Unitree GoTo. The diversity in the world of robotics today is vast, but we want to highlight the Unitree GoTo, one of the most affordable quadruped robots in its segment, with a price ranging from $3,000 to $4,000, thanks to Unitree Robotics' cost optimization strategy. Unlike high-end quadruped robots like Boston Dynamics Spot, which costs tens of thousands of dollars, the GoTo maintains a competitive price by using lighter materials, a simpler mechanical system, and focusing on mobility functions rather than integrating too many complex technologies such as industrial-grade sensors or advanced AI. Additionally, Unitree Robotics benefits from a strong supply chain in China, significantly reducing component and production costs compared to Western competitors. Another key factor in cost savings is the absence of robotic arms, as these require flexible joints and precise control mechanisms, making them one of the most expensive components in high-end robots. Beyond its attractive price, the Unitree GoTo still features advanced technology, making it a compelling option in the mid-range mobile robotics segment. One of its standout advantages, which we highly appreciate, is its ability to move flexibly across various terrains, powered by strong servo motors, AI sensors, and advanced balance algorithms. It can walk, run, jump, and maintain stability even when pushed or moving on uneven surfaces. Additionally, the GoTo is equipped with a high-resolution camera and a LiDAR sensor system that enables environmental awareness, obstacle avoidance, and autonomous navigation. These features make GoTo a versatile robotic platform applicable in fields such as research, rescue, security, and entertainment. One of the most important real-world applications of the Unitree GoTo is in security and rescue operations. Thanks to its stable mobility, it can be used to inspect hazardous areas, transmit real-time visual data, or even carry small devices to assist humans in emergency situations. For example, the GoTo can operate in areas at risk of collapse after an earthquake, or enter regions with high radiation levels that humans cannot access. Additionally, it can be programmed for entertainment purposes or AI research, thanks to its open platform, which allows software customization and the programming of unique behaviors. This flexibility gives GoTo significant potential in supporting humans across various environments. However, despite its strengths, the GoTo has some limitations. The most significant drawback is its lack of arms for grasping objects, which limits its physical interaction capabilities compared to humanoid robots like Walker S or Tesla Bot. While it excels in mobility and observational tasks, GoTo cannot perform actions such as picking up items, opening doors, or organizing objects. Furthermore, although it has a good balance system, it may still struggle on highly complex terrains such as muddy or rocky surfaces, as its quadruped design is not as adaptable as robots specifically designed for extreme environments. When comparing it to the Tesla Bot Gen 3, it is evident that both robots have distinct advantages suited to different purposes. The Unitree GoTo surpasses Tesla Bot in speed, reaching up to 11.2 miles per hour, while Tesla Bot moves at around 5 miles per hour, making GoTo more agile on complex terrains. However, Tesla Bot is superior in physical manipulation, featuring a humanoid design with an advanced mechanical system capable of lifting 10 kilograms and carrying up to 20 kilograms, something GoTo cannot do at all. In terms of application, GoTo is better suited for mobility, surveillance, and data collection tasks, whereas Tesla Bot is designed for household, industrial, and factory work. Although speed is not Tesla Bot's strong suit, its ability to perform practical tasks makes it a major breakthrough in human-assistive robotics. 3. From a financial perspective, UBTECH Alpha Mini is one of the most affordable humanoid robots available on the market today, priced between $1,500 and $2,000. This price point makes it accessible to a wider audience compared to high-end robots like Tesla Bot Gen 3, which is aimed at industrial and professional applications. To understand how Alpha Mini offers such value for money, we need to compare it directly with Tesla Bot and examine the key factors that contribute to its affordability. One of the most significant differences between Alpha Mini and Tesla Bot is their size and design. Alpha Mini is just 27 centimeters tall and weighs only 1 kilogram, which is drastically smaller and lighter than Tesla Bot, which stands at 1.73 meters and weighs 56 kilograms. This size difference means Alpha Mini uses less material, which immediately reduces production costs. Tesla Bot's larger size requires more advanced construction materials, stronger components, and more intricate designs, all of which contribute to its higher price point. Moreover, Tesla Bot's massive body size allows for more complex actuators and sensors that enable it to handle heavy tasks, while Alpha Mini's small stature is better suited for lighter activities like education and entertainment. The mechanical systems of both robots also differ greatly. Alpha Mini uses 16 small servo motors, which are far simpler than the advanced motors and actuators found in Tesla Bot. These servo motors allow Alpha Mini to perform basic movements, such as walking, turning, and interacting with users, but it lacks the dexterity and strength of Tesla Bot's advanced electromechanical system. For example, while Tesla Bot can lift and carry up to 20 kilograms, Alpha Mini cannot perform these types of tasks due to its design limitations. Alpha Mini's arms, for instance, are not flexible like Tesla Bot's highly articulated arms with independent control, which means Alpha Mini cannot manipulate objects in the same way. Its hands are designed as simple clamps, which limit its functionality to basic grasping. In terms of sensors and AI, Alpha Mini takes a simpler approach to keep costs low. It is equipped with a facial recognition camera and a microphone, allowing it to recognize faces and engage in basic conversations. This is adequate for its intended use in education and entertainment, where interaction with users does not require the level of precision that Tesla Bot offers. Tesla Bot, on the other hand, is equipped with a suite of advanced sensors, such as LiDAR, force sensors, and cameras, which allow it to navigate complex environments, recognize objects, and interact with them with a high degree of precision. These high-end sensors are crucial for Tesla Bot's industrial and scientific use cases, enabling it to work alongside humans in dynamic and potentially hazardous environments. Despite these differences, Alpha Mini offers several unique features that make it a valuable tool in its own right. One of its standout features is its ability to engage with users through intelligent speech and facial recognition technology. This allows Alpha Mini to respond to users, remember their faces, and even express emotions through its eyes and voice. It can converse, tell stories, and help children learn languages, making it a perfect educational companion for young learners. Tesla Bot, with its advanced AI, can perform more complex tasks like assembling products, performing healthcare duties, or assisting in factories where human-like capabilities are required. However, Alpha Mini's emphasis on communication and learning makes it an excellent choice for parents seeking a fun and interactive educational robot for their children. Another key advantage of Alpha Mini is its versatility within the realm of education. It supports language learning, helping children practice pronunciation, and it can read books aloud to encourage early reading habits. Some versions of Alpha Mini even allow for basic programming exercises through a mobile app, making it an ideal way for children to start learning about coding and computational thinking. This educational focus, combined with its interactive features, makes Alpha Mini a highly affordable option for those looking for a humanoid robot that isn't designed for heavy lifting or industrial use, but can still offer substantial value in a family or classroom setting. When we compare Alpha Mini to Tesla Bot Gen 3, the differences in their applications and target markets are clear. Tesla Bot is a machine designed to tackle complex tasks in a variety of professional fields, from healthcare to manufacturing. Its capabilities are geared towards assisting humans in physically demanding environments, performing tasks that require precision, strength, and adaptability. On the other hand, Alpha Mini focuses on providing educational entertainment, making it ideal for children and educational institutions. It offers limited physical capabilities but excels in user interaction, helping children develop valuable STEM skills and encouraging a love for technology. In conclusion, while Tesla Bot and Alpha Mini are both humanoid robots, their designs, features, and intended use cases are vastly different. Tesla Bot is a cutting-edge machine aimed at revolutionizing industries and performing complex tasks, while Alpha Mini serves as an accessible and interactive learning tool that is perfect for young users. The key to choosing between these robots lies in understanding their intended purposes and which features are most important for your needs. If you are seeking a robot for advanced tasks and heavy-duty work, Tesla Bot is the clear choice. However, if you are looking for a robot that offers an interactive educational experience for children, Alpha Mini represents a more affordable and practical option. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the UBTECH family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.